Our next speaker is Samson OOKO from the University of Rwanda. He's going to talk to us about Exhaled Breath Edge AI Inference for early prediction of chronic obstructing pulmonary diseases. And I'll turn it to you, Samson, to present. Thank you.
Okay, thank you very much for the introduction. I come from the University of Rwanda, African Center of Internet of Things, that is was created as a World Bank project to be able to train people on measuring on wireless sensor networks and embedded systems. And for our research, we are basically trying to see how we can be able to use TinyML to be able to detect diseases. The motivation for this study is that we find that many people die. In fact, over 4 million people die prematurely due to respiratory disease annually. That's according to the World Health Organization. And so having the challenges in Africa where getting the treatment is a challenge, processes and even consultation and even medical experts are hard to come by. So we thought of coming up with a solution that can enable a self-diagnostic kit that people can be able to use at home and check how their respiratory status is from exhaled breath. And so looking at having a portable device that somebody is able to exhale into the device, and then we use Edge AI to be able to detect whether somebody is suffering from COPD or not. The reason for using TinyML is basically in relation to the problems that we face in Africa that deal with connectivity, so that somebody is able to use this device even without connections in different remote areas. There are also privacy issues that relate to health data. And that also being able to reduce cost, because somebody can use this device as many times as they want, anytime, without having to go through the expensive processes that involve lab cost and such. And also being able to save energy, by not transmitting data most of the time, and that ensuring that the devices can last for a longer period of time. So our process basically to come up with a model, we are exploring the use of open datasets on COPD and also synthetic data. So we feed this into Edge Impulse, which is a TinyML platform that we are using for training. Then we generate a TinyML package that we compile on STM32 Cube IDE and Arduino IDE and generate an HEX that will later we use for Proteus. And also we are exploring how we can also be able to do that with the boards, that is the STM32 boards and even the Arduino NanoSense BLE. And the inference research basically that we are getting is whether somebody is healthy or not. And in case any anomalies are also witnessed, then we are able to detect those and also alert. From the preliminary results that we have with the flattened model, 95.3% accuracy, and with the raw-based model, that is, we got 96.9% accuracy, and using the PCA-based model, we got 92% accuracy. And so in looking at the real-time metrics from Edge Impulse, they estimated that we'll need 12 milliseconds inference time, 5.2 kilobytes peak RAM, and ROM usage of 92.9. But the actual performance on STM32 IDE was slightly higher than that, but still very minimal for execution on very tiny devices. We also looked at the number of impacts. The device that we are using, 8 sensors were used to collect data. So we are trying to see how much having increasing the number of sensors affect the usage. So we noticed that as the number of sensors are increasing, then you may need more resources on the devices. So if there is a trade-off, the number of sensors, and try to adjust and see what can take place. Then in terms of sensor performance, we looked at different sensors that we were used to collect the data and tried to see how each perform if, assuming that some of the sensors were faulty during inference. And we got that For prediction of COPD, MQ sensors gave us best result. And even when we try to combine different combinations based on the individual performance, a combination has over 90% accuracy. So if we have to trade cost to accuracy, then we can use 4 MQ sensors and basically be able to predict COPD at very good accuracies. Thank you very much. I think that's the end of that.
Thank you, Samson. I don't see any questions, but I have one. Did you also, in your sensor set, use any, you use audio sensors as well, or what types of sensors were used?
No, we are basically using gas sensors because we are.
And the second question,
detecting different bio.
Yeah, coming a little bit with interruptions, but thanks, Samson.
I want to thank our sponsors that made this event possible. So the premier sponsors, Newton, working on automated TinyML. If you were there a few days ago, they had a keynote explaining what they're doing. Executive sponsors are ARM, Edge Impulse as well, and Qualcomm. Sentient, and then our platinum sponsors, we have Infineon and Reality AI. Gold sponsors are Latent AI, SensiML, and our silver sponsors are EMEA, Greenwaves, HOTG, Imagimop, GISO, SEED, and ST. And with that, I thank you very much for staying on till the very last end, the last day of the last session of the last day. And with that, I think we can close the forum for this year. Thank you, everybody, for contributing. Thank you, Andreas, for also moderating this session.